Okay, the session is now being recorded. Okay, so let's talk about the underlying tech of Docker, right? But before that, let's talk about the agenda, right? What's the historical context, how the Docker came to be, what was the need for it, and then why we need containers. Okay, and then what are containers? Okay, why we need containers, but what are containers actually, right? And what are the Linux namespaces? Because containers, right, this containers is basically designed through, using some OS concepts, right? And those OS concepts are Linux namespaces and the C groups. We will not do any hands-on on Linux namespaces and C groups, but at least I will let you know like what are those concepts in OS and how it helps the containers to be like what it is. Okay, and then we also talk, maybe I will not touch upon the Docker architecture here if I feel like, if we don't have enough time. But then if I have time, I can definitely go to the next, like getting started with Docker, and there we can learn more about the Docker architecture. Here in this agenda, when I touch upon the Docker architecture, I would just let you know like, okay, you know what, Docker has multiple components. Those all components need not be on the same machine. So that is the agenda to, focus upon the Docker architecture here, but will not go in much depth right now. Okay, and then you can ask me anything like, at the end of this, you know slides or structure, whatever you want to say, you can ask me anything, like any, like you might even ask me like, hey, I'm trying to run the Docker but it's not working, and you can even share me the actual error code that you are getting and I can help you with. So don't worry about, like what should I ask. And even if you want to ask anything related to career related stuff, right, so you can ask me anything related to DevOps and, tools there. So yeah, that's it. Okay, so let's talk about the historical context, right? So earlier, the first, there was a traditional deployment. Okay, then comes the virtualized deployment, and then came the container deployment. Okay, so let's talk about the traditional deployment, right? So right now I have my machine, right? I have a machine, so I can basically start any server here, right? So I can start a Python -m HTTP server, right? It runs on my machine, right? And I can even prove it to you people. How? By just accessing this server. So it's just a static server by Python. It will kind of just, kind of serve all the files which are in this particular directory. Okay, so if I hit localhost port 8000, I can see all the files here, right? I can, if I want to download, I can download as well. So it's a normal server, right? So, but the problem with the traditional deployment is I can start this server, right, on port 8000, right? Okay, if I want to start another server, right, let's me open one more terminal, just like in Windows, just like in Chrome, right? You can, let's say I have this browser, right? If I can open localhost 8000 here, I can open another localhost 8000 here, right? I can open something like google.com, okay, in two different tabs, and then both the tabs I can work whatever I want to do. Like I can search something different here, I can search something different here. So in case, let's say there is a requirement where we have multiple servers, right, that we need to run on the same machine, and then, I want to use the same port 8000, it says already address already in use. So basically there would be some network related limitation, there could be other resource limitations as well. Okay, where two you cannot run multiple servers with the same port or same configuration on the, same server, right? So that could be a problem, right? So that was a problem with the traditional deployment. Then came the virtual machines. So in virtual machines, you are able to create, like, you can able to mimic the virtual machines, right, in your same machine. Let's say I have, for example, let me just show you. So this is my physical machine, right? If I have a traditional deployment, I would be able to only run one, Python server, right? Only one Python server on the port uh, 8000, right? The other servers, if I want to launch, I would have to choose another port for it. Let's say 8001, right? So that was the kind of a limitation. There could be n number of limitations if you run multiple apps on the same machine. Why? I will tell you that as well. So on the same machine, if you want to run multiple apps, maybe this Python uses Python 3.12, right? Maybe this one wants Python 3.12 and this one wants 2.7. Now you have to manage multiple Python versions on your same machine, right? I think this would have been. Do you face such problems when you work on your machines? That's my question to you people. Like you have two Java application, one uses JDK 1.8 and the other one uses, let's say, JDK 1.21, and now you have to basically, uh, work with Java environment variables, some environment Java home, and all those things, right? Has this occurred to you people? So that's the question to you.
Yes.
Hmm. So basically, then it makes sense that if we can isolate this app, okay, this app and this app, so that if it tries to use port 8000 and it tries to use Python 2.7 in this particular machine, it would not basically, compete with the other machine. So we can create the virtual machines in the same host machine, and then inside the virtual machine, we can run our server. So basically, virtual machines, what did it allow? It allowed to run multiple apps, okay, to run multiple apps. Let's say you have app 1, app 2, app 3 on the same machine, okay, and without basically overlapping with each other. Like they were not basically, colliding with each other because they were isolated. So running the apps in the isolated fashion, that was the main objective, and the virtual machine actually helped with it. So on the same machine, you can run multiple apps with different Python version, with different Java version, maybe, and also use the same port, right? So let's say here, the in the virtual machine, the Python app runs on the port 80, and here also it runs on the port 80, and yeah, it would have worked out for us. That's not a problem then, right? But then there was a problem. Okay, we'll talk about that. So why containers? Because we don't want VMs. I will tell you what is a virtual machine. A virtual machine is a kind of a machine which has its own guest operating system, right? Okay, so for example, let's say you want to run two apps, right? We have app 1 and app 2. Okay, this app 1 requires 200 MB of memory. Okay, I'm writing 200 MB, and this one requires, let's say, 100 MB, or maybe it also requires 200 MB, but that's not the point. It's just like 100 MB and 200 MB. And my physical machine, right? Uh, my physical machine, okay, has, for example, let's say it is a good big machine and it is having 16 GB of memory. Okay, fine. Okay, so if you have 16 GB of memory, right, like it's like 16 GB means, like, this much MB, and then if you have 200 MBs, right, so you can run 80 apps like these, right? You can run, basically, you can, ideally you should be able to run 80 apps on the same machine, right? But because you want the isolation, right, you would actually cover it in a virtual machine. So you will say that I am running this in a virtual machine and I'm running this also in a virtual machine. Okay, when you create a virtual machine, it's not just the app that you are running inside the virtual machine, even a guest operating system runs here, right? So just like, let's say my physical machine is on Mac OS, right? And for these two, applications, I'm using, let's say here I'm using Windows OS, and here I'm using Linux OS, right? Okay, so the problem here is, just to run the OS operating system, it requires a memory, and let's say it requires 2 GB memory, right? So 2 GB of memory is required by the Windows M, and maybe in the Linux it requires 1 GB, right? So you can very well see now, because I get the isolation with the VMs, right? But I also get the overhead of, the operating system, which eats up my resources, right? Which eats up my memory, and it also, it requires memory, it also requires CPU as well, right? So basically, this is actually eating up a lot of, like, just to run the 200 MB application, I am basically providing it a 2 GB of, memory, right? And that would mean that, if you can run, like, if all the apps like this you want to run in isolation and require 2 GB of memory, it clearly means that now you will be limited to how many of the applications you can run here in my physical machine, right? Maybe you can just run 8 or 9 apps, right? Okay, now is this a problem? Maybe it's not a problem when you are running with your own physical machine, but on the cloud, right? On the cloud, let's say if you get a machine of 2 GB memory, right? And it charges you, let's say, $20 per day. Now, because you want to run your apps in isolation, maybe you can only run 2 apps here, right? Now, because a virtual machine itself, even the app is 200 MB, all the apps are only 200 MB, but because you want to run in isolation, so you are creating virtual machines. So basically, you are spending this much money, right? And then again, you are going to run. So basically, if you could have run the 200 MB of app without the virtual machines, right? Ditching the virtual machine on this particular server, let's call it as server 1, okay, then you could have run, let's say, 10 apps here itself, right? But now you can't run, you have only 2 apps that you can run, and then you would require another machine, right? A cloud machine and another cloud machine. So yeah, it will eat up your cost, right? And most of your memory and CPU is getting utilized by the guest operating system. So yes, this is not a good way to solve a problem. It creates a new problem, which is a money problem. So probably because virtual machine gave the isolation, but then it was not adopted that much, because it also meant that there is a overhead of running the guest operating system, whatever I'm calling it, as a guest operating system, which means like it's running on the top of the host operating system, right? So yeah, this guest operating system is actually taking 2 GB of memory out of the host operating, host machine. So yeah, that's the deal. I hope everyone is good with this. Like, yeah, that's why we don't need virtual machines now. You can give me a thumbs up if you want to, like, if you are not willing to speak, giving me a thumbs up also works, right? You might feel like I'm not seeing your thumbs up, but I will show you. I have multiple screens, so I get to see, like, if you give me a reaction there, right? So yeah, now to solve this problem, okay, came the containerized application. So containerized application means you are able to run your application, app A, app B, app C, in isolated fashion without actually the overhead of running the guest operating system. You don't need it here. But then how it is getting done? Earlier we said that the multiple apps on the same the host operating system will basically interfere with each other. Actually, these containers are isolated with the help of you know some uh, Linux concept. We'll come to that later, but before that, i will talk to I will talk about, like, what are containers. Okay, what do you uh, mean by a container? So anyone wants to give me a, like, even though I have a slide here, I don't want you to just go and read the slide and tell me, but what is your current understanding of what are containers? So if let's say, if you are in an interview and somebody asks you what are containers, so what would you answer? So yeah, go ahead.
Containers are the isolated environments where you are able to put all your like it's a in a container. You will be able to put your code, your dependencies, all your OS environment variables in one container. And it's a container where you are able to ship your same environment. If you are able to run your application in your local environment, you are able to deploy that application at any environment. You just need to ship your container. That's the overall my
Hmm.
understanding about containers.
Okay, so you talked about two things. First, you talked about the isolation part, and you also talked about the shipping part as well. Like, you are able to ship your local environment to the, like, higher environment, right? Local environment to, let's say, QA and the prod, right?
Yes,
Am I,
yes,
if I have to just summarize it, right? So
yes,
yeah,
yes,
that
yes.
is okay. What about Hemant? What do you understand by containers?
As you said, as he said, I'm also thinking that the same. It is a private space where there is no we have only basic Linux or some OS, a bit OS, and we will include all our code and all our dependencies or whichever required to our code. We all pack it into a package, and then we are going to use it in some other ways, or we can share it to other persons.
So you and both peoples are saying this also, that containers are also, uh, you know all the dependencies are inside, right? All the dependencies are packed together, right?
Yes.
Okay,
Yeah.
so this is the third point I will say, like, okay, these are the 3 points. Okay, now fine, I'm okay with it. And even here you can see containers are similar to VMs, but they have relaxed isolation properties to share the operating system, and therefore containers are lightweight, right? Okay, and similar to VM, container has its own file system, like what you were saying, all the dependencies, right? Own file system, and they have their own CPU memory utilize, like, quota for it, and they are also decoupled from the underlying infrastructure. Fine, like, so you get this point, right? Like, even though I have this container slide here, right? Okay, this is not something I am going to speak in the interview, right? But even I will tell you, once we are going ahead with the session, I would say that, you know what you are talking about containers is the all the ecosystem. Okay, what does container give you, right? But actually what is exact specific, what is container and how it has been implemented, if you can give that at the end of the session, I would say it would be have been like, we have some, like a goal achieved, target unlocked, right? So let's go ahead and see what I want to mention, right? Like, I want, what do I mean? So the question here is, whenever you are saying that it provides isolation, shipping locally, and these and all dependencies back together, but the question is, if I go here, like, how does it do it? Okay, now you are blank, right? So now you are blank. Like, if I say, like, if you are saying containers does it, how does it do? And you are saying like container does it. So container, like, the thing is, you are not going the one level beneath it, right? Like, what's the in depth of it, and understand uh, that you might not need to basically involve with namespaces and C groups in your daily work. Like, I don't work with namespaces and control groups in my daily day-to-day job, but if I know those, if I know these things, definitely when I'm setting the Kubernetes cluster, right, I know what does C group mean there, and why does in Kubernetes there is a pause container. Okay, what does it mean? So I'm telling you that if you know these fundamental things, then you are able to relate it with the Kubernetes stuff and the Docker stuff, if you understand these two things, right? And all the containerization is based on this. So what are namespaces? So namespaces are feature of the Linux kernel that partitions the kernel resources. I don't know whether you remember the Linux architecture, but what are kernel resource? What is a kernel? Kernel interacts with your CPU, memory, hard disk, right? All the low level resource,
Part of
like
the
all the
Linux
hardware resources, right?
operating system.
So basically, namespaces actually partition the resources at the kernel level itself, at the operating system level itself, so that one process does not, a set of process does not seize a set of resources. So for example, let's say if I say there is a mount, okay, there is a file called slash mount, right? And there is another file called slash mount one, okay, one, okay, or let's call it better, let me call it as like mount a, okay, and there is another file which is mount b. Okay, that's fine. Now let's say we have a app A which needs some configuration, okay, and app B which needs another set of configuration, right? If they are both on the same machine, right? Okay, and you have app A has been written in such a way where it actually fetches this mount A directory and gets the configuration from this, and app B actually fetches it from the mount B. So that is particularly written in the code of this app B, right? Let's say both are the, let's say those both are written in Python. Which is the programming language you are comfortable with? uh,
Python.
Python.
is it both, for like, you are okay with Python, right? I am giving example of Python. Okay, yeah. So yeah, because you might have said like what he's writing .py, right? So let's say both are written in Python and there are some Python file. So what is basically written in the what would have been written in the Python file would be like to load a file, right? A load a directory which is mount B. Okay, fine. And in this it would be have written mount A, right? But let's say if there is a there is some developer who did not know that okay, he has to mount this particular directory, because see, mount a, it looks very conventional, so it's probably easy to understand. But let's say it was not mount a, it was something like mount xyz, a org name, right? And this was mount abc, right? Now it can happen that the app a developer might change the mount point, like might change the directory name from where they are loading the files, and then they can definitely do some mess up there, right? But if I create a container out of it, right? Okay, if I create a namespace, right? I create a namespace. Okay, so I'm not creating a container, I'm creating a namespace, right? And saying that in this particular namespace only the mount xyz belongs. Okay, so this is a namespace a and this is the namespace b. So I say if this is the namespace a has this directory, so that means only the processes and the apps that are attached to this namespace will get to see this mount xyz. Okay, if a process in this namespace, okay, this is a namespace for example, okay, if a process within this particular namespace tries to even like in the code they have said that let's load the directory, and they have given the path as well properly, but because this mount abc, right, belongs to the namespace b, they will get file system not found error. Did you get that? Like when you try to load a file which does not exist in Python, what happens? It says, right, the operating system gives the error saying that file not found, right? So at the operating, so you are not restricting the apps to not interfere with each other just because they don't have that particular code inside it. It's like at the operating system level, if they try to you know read this particular directory, they will not be able to read it because they belong to a different namespace, and to that particular namespace this particular resource was not attached. Is that good with everyone? So now you know what are namespaces. So you can basically have different types of namespaces. I just talked about the file system namespace here, but understand there can be different, like different resources. For example, this is a what is this? This is a file system, right? But what about network resources? Just like in your machine, right, you have Bluetooth, you have Wi-Fi, um, you have LAN cable, right? So you can say that hey, only let me create a network namespace, okay, for the application a, okay, a network namespace for this name, like a network namespace, and only the application that belongs to that particular network namespace can use the ethernet uh, interface, network interface. The other can only use the Wi-Fi interface, right? So you can also party, like create different network interfaces and isolate them as well, right? So that level of you know resource isolation, you can get it from the operating system level itself. So even you can tell that only you know yeah, I would say like we will come to this later, but there are different types of namespaces. But majorly I would have I wanted to give an example, and I think I did it using the file system namespace, that at the operating system itself it kind of provides that isolation. So there's no chance that app a can read the app b's configuration unless it is attached to the same namespace, right? And the namespace is shared. Otherwise it is like at the operating system level itself, like it's a different thing. So chances of developer doing any mistake or misconfiguration is very 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 minimized. So even the environment namespace, right, for example, there could be something called environment variable java home, right? Or java version, something like that, java version, or python version for example, right? And this can have java version as 1.8, and this can have java version as 1.9. Okay, so it can happen. Now you might say like, does that mean java is installed at two multiple places, like inside two namespaces? I would say yes, but we'll come to that later. But yeah, definitely even the environment name, like there are different types of namespaces which are isolated. So when app a has to read this java version variable, it will get 1.9 but not the 1.8, and if app b has to read the java version environment variable, it will get 1.8. Okay, so that is your namespaces. Let's talk about the other thing, which is control group. Okay, so a control group, what does it do? It sets the limits on the CPU, memory, disk IO, and network, right? For example, let's say I have 2 GB of memory. Okay, I can create a control group, okay, CG1, and say that it can only any app, like total apps, whichever apps are basically associated with control group 1, they have a 500 MB limit, right? And whichever are, kind of associated to control group 2, they have, let's say, 1 GB of memory allocated. So all the apps that belongs to the control group 1, so there could be n number of apps that are, associated with the control group 1. So app 1, app 2, app 3, right? App 1, app 2, app 3. But what is the total memory they can utilize? They can utilize till 500 MB. If they go beyond it, maybe the control group will kind of, stop those. Okay, and same with the control group 2. Okay, and it's not, now control group does not only control the memory, it can also control the CPU. So let's say you have 4 core CPU, right? Let's say 10 core CPU, you have a big machine, so you have 10 core CPU, right? So now you can say that only this control group 1 will have only, let's say, 2 cores of CPU, okay, and this will only have 4 cores of CPU, right? So the apps that are, inside the control group 1 can only use till 2 core of CPU, and the apps which are inside the control group 2 can only use till 4 core of CPU. If they go beyond it, probably the process would be killed. Okay, is that good with everyone? Like, you understand now what is namespaces and what are control groups, and these are the only two things that are required to basically run the processes or run your apps in an isolated fashion. And both these two things are a Linux feature. That means containers cannot exist on a different operating system. If you want to work with containers, you have to use a Linux machine. Now you might say, like, I have a Windows machine, but I'm able to run their containers, and me myself, I'm using a Mac machine, right? I'm using a Mac machine, I'm able to run container, right? So what happens implicitly when you install Docker is that a Linux virtual machine is installed. Okay, so if I have to show you, I can also show you that as well. Okay, so in this settings, probably I have some resources, right? So these resources which I'm setting, right, CPU limit and the memory limit, what are these? These are the limits on the virtual machine, the Linux virtual machine, that on which the, you know containers would run. It's not the limit for the individual containers, but it's limit for the whole Linux virtual machine. Okay, so that is what Docker is doing. It is actually installing Linux on top of your machine, and then, you are able to work with the Docker. So for example, let's say I said, like, you have the host machine, right? You have the Docker on it, and then on the Docker you can run apps, right? App 1, app 2, app 3, right? But that is true when you have a Linux operating system, right? When you have a Linux OS, that's fine, you can basically not need a virtual machine. But when you are on a Windows or, Mac, then you have your host, then you have a virtual machine, which is the Linux virtual machine, but you, at least you need only one virtual machine, right? You don't need multiple. And on this VM Linux, there's a Docker platform or Docker engine, you can say, it is running. And then you have, app 1, app 2, app 3, app 4, app 5. Okay, is that good with everyone? Dockers cannot, containerization does not exist um without Linux. Okay, fine. Now let's talk more into detail, like what are name, like, what does namespaces mean? So there are multiple types of namespaces. So one of which is a user namespace. So for example, right, let's say if I say, who am I, right? Who am I? I'm Sagar Moria, right? If I run a container now, Docker run, right? Docker run busybox. Yeah, Docker run busybox, and I will run like this: Docker run -it busybox, and run this command there. Okay. So I have a user on my local machine, which is, who am I? Sagamore, right? If I just search here, who am I? It's root. If I, so you get that, like, it's a root user, and I can basically see all the users on this container, right? I ran a container, but probably the users that I create on my local machine, on my host machine, that are not visible inside this particular container. And if I run a command to create a user here, right, that will only exist in this particular container and not the other one. So basically container have the unique, isolated user namespaces as well. So the users and the groups, right, the Linux users groups for each individual namespaces could be different, right? So basically if I create a user namespace, right, a user namespace, okay, ns for a, right? So all the apps, right, that are running under this user ns a can only see, let's say, Sagar Moria, okay, if I'm creating the user there, okay. But if there is a user namespace called b, okay, and there I'm creating one of the user as always, right, and I try to access, like any app that tries to access the user namespace b's users, right, they will not be able to get it. It will be like, yeah, user not found. Okay, did you get that? So that is your new user namespace. So your host users are not shared with your containers, and even within the containers, let's say you have app 1, app 2, app 3 containers, and all of them have their own namespaces, right? So they have some users created here. Let's say it's a Nginx user here. Here it is Jenkins user because it's a Jenkins app which is running, and here it is running, something like, yeah, it could be someone's name, right, like Hemant's name, right? So probably all of, like, app 1 only gets to see this user. It cannot basically access this particular user's details. So all those users are, kind of isolated with each other. Are we good on this? If not, okay, we are good on this. So that is your user namespace. Then there is a process ID namespace. So understand that a process can, like, if I run a command, right, if I run a command here, ps minus ef, I can see all my host machines process, right? But if I run the ps minus ef inside the container, I only see the sh command and the ps minus ef I just executed, right? So basically, yeah, this is your process this is your process ID namespace, where a set of process can be only viewed if they are belonging to a particular namespace. So my host namespace, like, this container is running, and it can see only those, process which are running within this particular process ID namespace. Okay, for example, if I run another container, right, so let's say docker run another container, right, and here if I run the ps minus ef, you will see, right? And if I want to run some command, let's say, let me run a command sleep for 500 seconds, okay. Sorry, I should not have written like this. Yes, and then do ps minus ef, you will see there is a sleep process running, right, within this particular container, right? But if I run the same here, you will not see it, right? You can't access these. So basically this, let me call it as a container a, and this is container b. So container a does not get to see any of the child process of the container b. Okay, fine. So this is your process ID namespace isolation between, two containers. Okay, and then I've already talked about the network namespaces. So for example, just like how I ran Python, server on the same port, and it did not allow me. But if I do the same thing, I run some server on port 80 here and port 80 here, it will allow, because those both are in a different network namespaces. So they have their own IPs, their own set of, ports, and their own network firewalls, right? Everything, like network, everything is, different for this and different for this. Okay, and amount namespaces are just like the file namespace, as I mentioned, right? So it's that same thing, right? So a particular container can only see the file systems which are mounted in that particular namespace. Okay, inter-process communication, I will just say that I'll not go much in detail, but just like you can see that a process, if I have a container and I can see only a set of processes, maybe I can only interact with only those processes, right? So the inter-process communication also governs, like, okay, if a one process can basically interact with the other process or not. So yeah, The process which are under a particular IPC namespaces can only interact with each other. They cannot basically interact with the process which are under different namespace. Okay. A Unix time sharing namespace. So this allows a single system to appear to have different host and domain names, right? So for example, let's say, what is the host name for this? This is E26127, right? But what is the host name for the other container? It would be something different, right? And even the date, right? The date is 26:05 o'clock. It is in UTC time zone, right? So otherwise, if I have to change my machines, like I cannot have multiple times in my machines, right? So basically, this both the host and the domain and even the date, right, can be different in different container if they are belonging to a different Unix time sharing namespace. Okay, are we good with this? Like these are the total types of namespaces which are like these only are required to basically create the isolation of a process, right, or application. Are we good on this? Okay. Now let's get to the next part then. Okay. What are the C groups? We have already seen that it basically does limit the the amount of CPU memory a process can use. Okay, but it also has more features. For example, you can also prioritize like which C group has a more priority. So even though they are overlapping, they have a competing, there are two C groups competing for the resources, but who wins, right? So you can have those prioritization set up. You can also do the accounting as well, rather than see, you can definitely check the, what do you say, there are some command like top command, right, where you can see the each individual process CPU and memory, right? But if you want to manage multiple processes and keep it inside a control group and actually see the group the process in a control group and then see their resource utilization, then you can directly go and check the control group resource utilization. So it helps you in a better accounting and monitoring, right? Okay, so let's say multiple process belong to a control group 1. Okay, so you can just say, hey, I just want to check like what's the total CPU and memory being utilized by the process which belongs to the control group 1. So it helps you with the better accounting as well. And you can even stop, freeze, or restart processes with the control group. And now you might say like I can do that even with the Linux commands, right? I can always kill a process, I can always stop a process, but you can only do it for one process, right? But if you have multiple processes belonging to the same control group, you can directly with the single command you can basically freeze, stop, or restart all those service, all those applications which belong to that particular control group. Okay, are we good with this? So what are namespaces, what are control group, right? These are the features. Okay, are we good with this? If we are not good with this, we are bad with this, so please probably ask a question then, or at least give me a thumbs up. Okay, fine. So now comes the question here. Linux was not introduced. Linux already had the namespaces. Linux already had the control group, right? Why would we need Docker, right? So can't Linux has its own containers, right? So yes, there was something called Linux container, right? And it was released in 2008. Okay, and we'll see that when did the Docker came to be. But yeah, in 2008, there was a technology to create containers without the need of Docker. Okay, and LXC was a user space interface. Basically, LXC gave you the APIs to control, the control groups and namespace and create a container out of it. So basically, if you in the LXC, if you said that, hey, I want to create a container, so it basically behind the scenes created that, namespaces and the control groups so that you can isolate a process, right? LXC is a free software. Now you might say like maybe it was paid, that's why it was not well adopted, but it was a free software and it was having this GNU, yeah, like a typical open source license. And you can also like, and LXC is not dead. Okay, LXC is still running. Okay, so you can always find more details in the linuxcontainers.org. So Linux had its containers. It's like you didn't need Docker to run containers. Linux had the namespaces. Linux has the control groups. So containers were well before Docker came to be, right? Now, then what happened with Docker? Okay, so Docker initially when it came, it used LXC and it was released on March 2013. So it's like, 2013 minus 2008, right? How many years? After 5 years of actually launching the containers, the Docker came to be, right? So it was 5 years. There was a period where we had the containers but not the Docker. Okay, so at the time of coming, Docker actually used the LXC. So basically, Docker made the LXC calls behind the scenes to create the containers, right? And Docker was written in Go programming language. And on top of this top level, now you might say, like, if LXC was already there, what did the Docker do? So LXC was only, you know, written in such a way it where it allows you to isolate the process. Okay, so you can run multiple processes on the same machine in an isolated fashion, right? It was more of a sysadmin thing, right? But Docker offers a good amount of high level tool with several power functionalities. You can see more details here. Let me click this. What are those details? Those details are page not found, right? And why this is that? Because recently they have removed this page on the Docker com, engine FAQ. Okay, for example, let's go to this, right? Recently there was a FAQ, section, but now they have removed it. But then how would we come to know about, like, Docker versus LXC? And recently when they have removed this FAQ, they have also made sure that they have created a blog out of it, so that if people have this question, like, hey, you know what, LXC is already there, so you say that Docker uses, like, Docker used LXC, so what is Docker on top of LXC? So Docker actually, uh, yeah, Docker enhances LXC, right? So Docker allows you to package the container in a lightweight portable unit so that you can ship it from one place to another. So by default, when people were saying about containers being able, using containers, you are able to ship the, your code and dependency from different environment. So yeah, understand, like, that's not possible using just the container. Yeah, definitely the container ecosystem allows it, but it's not what the containers are. Okay, so coming back to the previous question, my question here is, what are containers? So what would you answer now, given that I've talked about this much? Has your answer changed? Like, what are containers, or is it the same? I'm okay to, like, you can. Okay, always actually ask the question, do we need to configure control group before deploying applications? No, you don't need to do it, because even though containers are using namespaces and C groups are done using that, but LXC handled it for you. Okay, creating the user namespaces and the control groups, and even Docker also handles it for you, right? Uh, because it actually was using LXC. Right now, does it uses LXC? No. Now, right now, Docker directly interacts with the namespaces and control groups. So, but when it was first launched, it used LXC. Okay. So my question here is, what are containers now for to you people? What would you say? Or is it the same? Like, if you want to say that, hey, we want to we'll repeat probably the same thing what we said earlier, so just tell me, like, okay, it's the same thing that you want to repeat. Maybe put it into the chat, and I know that, you know that's why you are not speaking up. Yes, so I will say, like, now, if I have to, if I get a question now in an interview, I will just say, if somebody asks me what are containers, so I say containers allows you to run. I will not say even allows you, I will say containers are processes running within a namespace and control group. That's all. Okay, so what is a container? A container is, if somebody asks me, like, what is a container, I will probably, and he gives me a blackboard or the whiteboard, I will just say, like, here is a process, and This is the container. Now he will say, what is this dot dot dot? This dot 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 is the are the namespaces, different types of namespaces, and control group. And this process belongs to these namespaces. Okay, the user namespace and the other, like probably the namespace names would be the same, just the type of namespace would be different, and it belongs to the same, like it belongs to a control group. So that a container. And now my now question would be like, can multiple processes run within the same container? I would say yes, why not? Like you can have n number of processes running within the same container. Okay, so I hope this you people get this, like what is the answer to what are containers. Containers are process running within a namespace and control group. Are you good with this? Now you might say like, if we actually answer this, probably we like the person is going to ask us more. Yes, and that is what I need. That is what I that is what I want, is that you, if somebody like, see, if somebody asks you what are containers, and you would have given the existing answer, right? Like, which is containers allows us this that, probably they will understand that you are just have the basic knowledge. But when you say when you just and see, I'm not saying to elaborate. I'm not just saying that if somebody asks you containers, give your 2-hour lecture to them, right? I'm just saying that use that specific name so that the interviewer understands that you are the real deal. So if there is a job opening for one person, okay, one DevOps person, and 500 people are applied, probably you want to be the one and not the other 499, right? So if you say this, the interviewer would know that, hey, he knows about namespaces or control groups. It can happen that the interviewer itself might not know about the namespaces and control groups, right? In that in that case as well, he will ask you, right? He will ask you, like, if I have to ask you what a container is, you would have given me a container as a process running within a namespace and control group. I would be like, what did he say? I will say, okay, what are namespace and what are control group? And then you would have mentioned, see, in Linux there's a concept called namespaces and there's a control groups allows you to, and then I will select you. Right? So there are two cases. Either the interviewer already knows about the underlying tech of the containers, he is going to select you. If he doesn't know, he will ask you and you will still tell the answer. So he will select you. So, and it has happened with me that there were 3 rounds of interviews scheduled, right? So you always have a round one, which is basics, and then in round two, they dig deeper, and round three, they dig more deeper. It has happened with me now recently. Mostly it has happened recently with me, like in last 3 or 4 interviews, where people had said that they will taking 2 round or 3 round, but then in the initial round itself they are saying like, hey, you are selected, we don't need to waste more time. Okay, let's not waste your time, our time. We know that you are the real deal, let's hire you. Okay, and that is where I'm talking about, like, you give that specific answer to just like, and whenever from now onwards, if somebody asks you what are containers, you try to put the, like, okay, whatever you want to give the answer, you give it, but at least mention that containers are contained using the namespaces and control groups, which are the concepts of Linux. Okay, are we good on this? Because I have done this, and I know, I can tell you with my experience that 3 rounds of interviews was done in just the 1 round. Okay, and nobody, very well, nobody in the interview will say like, hey, can you create me a namespace? And you will say like, no, because no need to. I on the day job, I don't need to create the namespaces, but I at least know why, how the containers are you know created. So that is what LXC was. LXC was just allowing you to create the namespaces and the control group, right? But it was not, and it was running the dependency, like the dependency management was your task, right? Okay, is that good? And then came the Docker actually enhanced the LXC, said that, hey, if you are able to run your containers within the namespace and control groups, okay, like your process, I can also package that you know container and create a Docker image out of it, and we can ship it to somewhere else. And there also it will run within a particular namespaces and the control groups, along with the code, along with the dependencies and everything. That happened with Docker. Okay. And one more thing I want to stress on. In the slides, I have mentioned about, let me show you. Uh, in the slide of the Docker, I have mentioned about what? I have mentioned about Docker is written in Go programming language, right? Why do I need to stress about it? Because most of the tools now in the Docker ecosystem, right, like Kubernetes, Prometheus, Grafana, you name the tool and it is written in Go programming language, right? So just because Docker and containerizations were, containerization was written in Go programming language, most of the tools around it is also written in the Go programming language. So my question is, if you know Python, you know JavaScript, you know Java as a coding language, right? What is the next programming language that you should start reading up so that you get a better job in any, DevOps role? Is the Go programming language. Okay. I'm not denying the fact that you don't need, I'm not saying that, hey, ditch the Python, ditch the shell scripting, you stay with it, that's not a problem. But if you want to level up, the Go programming language is a language you should go ahead. Because why? Because there are sometimes the limitations from the tool itself, right? There could be some limitations from the Docker tool itself. At that time you want to contribute to the Docker, and it's a open source, you know open source software. So if you want to enhance the features of this tool, or let's say Kubernetes tool, or maybe let's say Grafana, Prometheus, like you will be able to work with the community if you know Go programming language, right? And you will be able to even understand the in depth of how these tools are working. But you have to first learn Go programming language. I can definitely go dig deeper into the Docker, how it has been structured and everything, but it will be just a theory, right? And why would theory matter to you, right? So unless you know the Go programming language, okay, or read about it, it's you I'm not saying that you will not be becoming a DevOps person, but understand, you would not get the top notch, jobs. Okay. Are we good with this? Like, why did I stress on the Go programming language? Otherwise I could have written 10 lines here, 10 features of Docker lets you do this, Docker lets you do that, but I used only those details which was required to tell you why the Docker came to be. Okay, fine. uh yeah, so if you want to ask me anything now, you can ask me. Other than that, we can definitely go on to the next section. So I give you 2 minutes of break as well, because it has been around an hour. And after a 2 minute break, we can come. Okay, what is the amount of break that you want? 5 minute break, 6 minute break? I can give that much break so that when you come back, we start in a good shape. 5 minutes. Let's take a 5 minute break and let's come back and probably have some tea, have some coffee. And what's the agenda after we come back? Let me just show you that as well. I have the second, which is getting started with Docker. Okay, so yeah, definitely we'll run some Docker commands, and maybe we'll see some Docker architecture as well, right? So, okay, let's take a 5 minute break.
Timer activated for 5 minutes.
Meanwhile, if you have any questions, you can put it into chat. Once I come back, I will look at it. Okay. I'm disconnecting, like I'm basically going on mute and switching off my camera. Hey, hi people. Are you back? If you are back, just type back in the chat or maybe give me a thumbs up so I know that you are back. I see Hemant giving thumbs up and so is the Wiz. So yeah. Okay. So let's open this another slide. Probably this will be more on hands-on, right? It just that gives me a structure because I can always keep on talking about, I can keep on talking about Docker, but then there should be a structure as well. Okay, getting started with Docker, right? So if you want to get started, what are the agenda? So we'll first talk about the Docker architecture, okay, and how to containerize an application and create multi-container apps, okay, and we'll see that how to better create a multi-container app. There's a crude way to do it, but then there's a better way to do it. So we'll see Docker Compose, and then you can ask me anything, okay, at the end of the session. So before actually jumping in to uh, further, okay, to getting started with Docker, I would like to ask, like, how do you get started with any tool? Let's say I say there's some tool, right? There are so many tools in DevOps. If you have to learn it, how do you go about it? That's my question to you people. So feel free to, you know, give the answer.
To
Yeah.
like understand the architecture part, then we need to install that application on our Linux or Windows terminal, then operating system. Then we need to like apply that real application.
Okay. Fine. What about Hemant?
Yeah. What are the features or services that providing the tool? First of all, we want to know that, and then how the syntax will be. So to use the features, or what will be the syntax for each and every one thing.
Mhm. Okay. So if I have to learn Docker, okay, conceptually I know like what are the features with the Docker, right? Because we went through the first section. So what does Docker do? Docker allows me to create containers, right? So what would be my next step to learn the Docker?
Installation.
Yes, installation. Installing the Docker. Any tool that you want to learn, you first need to install it on your machine. I can keep on like, you understand that, right? Even though I will show you all hands, like, hands on everything, you will only understand it once you do, or maybe if you have already done stuff, doing stuff, then it's fine. You can understand from it. Other than if it is very new tool for you, like it is the first time that you are basically reading about Docker, then probably you need to first install Docker on your machine. And to install Docker on your machine, it's fairly simple. You just need to go to the a site called Docker Desktop, and that will do your job, right? I do have Docker Desktop already installed, but I will not go about the steps of it. Why? Because my machine is different. Your machine could be different. Your machine could be Windows. Your machine could be Linux. So based on that, you would choose the how to install Docker Desktop on Windows or Linux or maybe Mac, right? It depends on the operating system that you have. So, but yeah, at the like, if you don't have Docker installed on your machine right now, there's no point of like, feel free to basically drop off, okay? Or else, what I'm asking you people is, do you have Docker installed on your machine or not? Yes or no?
Yes, yes.
So Hemant says yes. I hope always for always also it's
Yes,
yes,
yes.
right? Okay, fine. So I did not see the thumbs up. That's why I was saying.
Okay, okay.
Uh, okay. So yeah, let's start then if we are good with that. So first of all, I will talk about the the Docker architecture. Okay. I will not bore you with this image, but I will just like to say that Docker client is what the Docker CLI command that you run, like Docker command that I ran, Docker run IT and everything. That was the client. Okay. Where is the actual container running and actual images staying, it's the Docker host. That is your Docker host, like the Docker daemon, that Docker engine basically, which runs the container and contains the images, right, to run the container, right? So what are images? Images will get in depth of it, images, but images are the blueprint to run the process as a container. Okay, so the you want to run process as a container in isolated fashion, but what to run inside the container, which code to run it, what dependencies you have to bring in, that is defined in the images, right? So this Docker images, like this images concept was not there in the LXC. LXC said that, hey, you bring me all the code, everything, you keep it in a file or something, like you provide it, and I can only just create the username spaces and the control grips to run it. But Docker does allows you to provide, all the dependencies, everything packaged together, and then run it inside the push that code base, like push that all files inside the container and then run the process as a container. Okay, so that is your Docker host. And then if you like, now this Docker host does not have all the images, right? Like it can only fetch the images from a registry, and those registries could be in the Docker hub. Okay, Docker hub can have some registry. If you want to have some Docker extensions, right, you want to enhance the features of Docker, so there could be some extensions, there could be some plugins. Those are basically staying in the Docker registry, which is dockerhub.io. Okay, Docker hub.docker, I guess hub.docker.com, sorry, hub.docker.com. Okay, so here you have, like, if I want to search for nginx image, I can get it. I can get even the Python images as well, right? Whatever I want to search, I can get it, and my Docker host can fetch those images from the Docker registry. Okay, Python, I should have written Python. Okay, so why I'm so if that is the thing with the Docker architecture, I just want to say, you already are seeing that Docker host is running on my machine, right? So the containers are running on my machine, but the registry is somewhere different, right, on the hub.docker.com. But the Docker client, where is that? Docker client is also, I'm running on my machine, right? Does it need to be on the same machine? No. Okay, so that means my Docker client can actually interact with the machine which is on the cloud, right, which has the Docker daemon running. So Docker, this my Docker version, if you see, okay, so it has all the, this is a Docker engine version, right? And this is the Docker desktop version. It talks about the, what is the engine version, what is the container D version, what is run it, run C, like different components of, Docker desktop. So this is your server, right, which is the Docker engine running, where my Docker CLI is connecting to, and this Docker desktop is also installed on my machine. So for example, what I mean to say is, it's not necessary that if I'm running the Docker command from my machine, okay, the engine, right, the Docker daemon, the Docker engine needs to be on the same machine itself. It could be on a different machine as well. Okay, so I can just install the Docker CLI and not the Docker desktop. So my machine which has the Docker CLI, okay, will be able to run containers and interact with the containers on a different machine which has the Docker engine. Okay, so it will connect with this. And how does it do it? Like, what's the connection? Like, it creates, there is a socket file basically, right? So I will not basically show you that socket file, but yeah, understand there is a socket connection between the Docker CLI to the Docker engine. Can I, so now the question is, I can definitely, so if I have to give you an example, right, for this, so I can definitely reach google.com from my, client, okay, my browser client. Google.com is not running on my machine, but I can also reach to a server, okay, which is running on my machine, right? So for example, first I have to start it though. Okay, so now if I run, so here in this case, Google case, my client is on my machine, my browser, but the server, right, which is giving the response, google.com, is somewhere with the Google, right? But in this particular case, I have the client and I'm making request to the server which is also on my same machine, right? But it's not necessary in a client server architecture that both your client and server need to be on a machine, same machine, but it can be there as well, right? So you get this point, right? Like in some advanced use cases, you will see that you are basically using the Docker command on your machine, but actually the containers are running on some different machine and you don't have Docker engine running on your machine. Okay. In that scenario, in that particular scenario, you need not run a virtual machine on your. So let's say if you need just the Docker CLI, right? You have a Docker CLI to be installed on your machine, and Docker desktop or the Docker engine needs to run on somewhere else, right? So because the Docker engine is actually supporting the containers, right? So this needs the Linux operating system. Okay, this needs the Linux operating system, but the Docker CLI, okay, just the Docker command line does not need a Linux, so you can have it on the Windows or Mac OS. That's fine. Okay, I just wanted to stress on this point because in some advanced use cases that is the case, and you don't worry about it. Okay, that's all I wanted to talk about the Docker architecture. So the components, I think I can definitely hand you these slides, but I don't think I need to talk much here. So I just wanted, like, I can go through these slides, but essentially what I told on the first slide, that's the same here. So what I was saying, Docker client and daemon communicate with the REST API, Unix sockets or network interface, right? And Docker desktop is an easy to install application for your Mac, Windows, Linux, and it has so many things with it. Docker desktop comes with a lot of many things. Out of that is a Docker daemon, which basically runs your Docker objects. Like one of those is images and containers, and the other ones are also there, but we'll come to that later. Okay. So let's try to containerize an app. Okay. So there's a repo. Okay. Let me clone this. Do I have it already cloned? Let me see it. What is the name? Hello world. Hello world. Yes, I do have it. Okay. So if I want to run this hello world, how would I run it? Because it's a Python. So probably it's the best way to run this is first read the readme.md, and it says that these are the steps which I have to execute, right? So basically I have to run this and this. And I hope you understand what are environments, virtual environments in Python. So basically I'm kind of doing those things and then basically installing the requirements. I'm basically, this is a Flask app, I guess. And that is what, Flask is getting downloaded. And then the Flask app, hello world run. Okay, fine. And if I want to run this, check this, yeah, it works fine, right? Good. But then I want to containerize it, right? To containerize this, you have to, just like how you have steps in the readme.md to run it manually, same way to containerize it, you first have to create an image out of it, and probably you have to write a Docker file. So basically you have to tell Docker to create an image, but the steps have to be written. So in the cat Docker file, let's see what is there. Okay, I have that here. So cat Docker file says that use the Linux platform. Okay, this is the platform Linux. So basically container will be based on the Linux AMD64 architecture, AMD64 architecture, and bring this particular base image Python, so that I don't need to install Python from the scratch. Okay, my host machine had the Python. Otherwise I would have also said in the readme.md first install the Python and then go ahead, right? But by default the Mac comes with Python installed, so that's fine. But by default the containers, right, would not come with the Python installed. So you can always base your, rather than basically installing Python in your image, you can start from a Python base image and then work after that. So basically I'm copying the requirements.txt from my host machine inside the image. Okay, like basically I'm putting that, copying that into the image, and then I'm running the pip install requirements.txt, and then the hello world py, also I'm the Python file, I'm copying it there. Expose 3000, I'm telling like, okay, this is the 3000 and this is the command I'm running it. Now you might say like, hey, this is Docker file, right? And it is not identical to what I am doing in the readme.md, right? If you are aware with the Python, can you talk about it? Like, why would I do it something different in the container versus, you know, when I'm running it on my actual machine? If you are aware with Python, give me an answer. If not, if don't have any idea about it, then fine. You have both the things here, right? Like how to run it from my local machine and how to run, like when I'm creating container, how I'm trying to create a container. Anyone wants to give something here? Want to contribute?
Actually, I had a question regarding this. You have written a Docker file, right? So
Mm-hmm.
on platform. So here you have written the base image, right? Then after this copy. So this copy commands, where are these files coming from? Like
From
copy
my
or copy.
yeah, the commands are coming. So when I will run the Docker, like when I have to create the Docker image, I will say Docker build, okay, and it will use my Docker file, okay. And what is the context I'm giving to the Docker build command, okay, to create the Docker image, is the the current working directory. So it will try to find the requirements.txt from the current working directory. So
From GitHub or local machine.
this is what dot means. What if I do the
So
cd dot?
current date.
So yeah, that is what it is.
Okay, so that hello.py is in your current directory, right? Okay.
Let's see it. Yes. So many times people don't understand what does this means, right? They think like, okay, whenever we are creating the image, we just give dot, but it's the context, like what is like what when you said, right, requirements.txt, from where, from wherever you are giving the context, right? So the file path you give it. So if I want to run the Docker build command here, but my files are in some different directory, I have to provide that. Is there a way to provide the Docker context from a remote URL? Let's say Docker context remote URL, right? But then you have to worry about even that, the remote URL is publicly accessible or not, right? Create a, like, just search Docker context, okay? So probably it will talk about.
Actually I was assuming that that file is located in your GitHub, and you are pulling from that GitHub, and so that was my concern. Actually, I didn't
Mhm.
know that. So that's the concern.
I just want to check the Docker build command, like, because what I'm trying to say here is like that information is not so, you just have to be curious enough, right? Just like you were curious here, whenever you are running the Docker build command, right? You have to just be curious that, what does the dot stands for, okay? Docker build CLI, maybe I will search Docker build CLI. I just want to see the examples for it. Uh, Additional build context. So you see here dot everywhere when you do that Docker build, it does that. Okay. And I hope they mentioned it. What does it mean? So they are saying path, right? So probably they will mention about like what are the path. Yeah. If nothing, like, see, if it is taking a lot of time, what I can see is Docker build dot Stack Overflow. Probably somebody would have answered, just like how I'm answering here. Probably somebody would have answered on the Stack Overflow as well. What is a Docker context or something like that? If you see dot located in the current, that is final. Okay, Docker build context. Hmm. So yeah, this is what they are trying to say. Where they are, okay, in the core. See, if you want to learn something, you can definitely go into, like, somebody has to go into the core concepts and just see, okay, what are the build context? A build context is a set of files that you can build, your build can access, right? And that
Hmm.
is a positional argument, and that is either path or URL. So if you want to give a URL, you can also give that. For me, it didn't make sense, because if it is the GitHub, right, and I have cloned that repository, okay, that's what I mentioned, right? Like, I've already cloned that repository. So a dot would work, right? And I would really like everyone to do a Docker build from their local, like, whatever they have. Otherwise, it will always, even though I change some files in my local machine, it will not fetch those. It will go to the remote GitHub only, right? That I don't want. I would probably better do a git clone or git pull of the latest code and then run the Docker build dot, right? So I think that's a general practice, right? I would say in any
Yeah,
organization.
I was just curious. So actually, my curiosity was like the file, hello world.py. So this is a current file. Okay. So whenever you want to make the changes, so you will be making the changes in the GitHub repository, and then pulling the same again the GitHub text file, and then again creating a Docker image out of it. Right. This will be the continuous process, right? So that's
Yes.
what.
I would not 100% agree. You talked about I will push the code. I might not see. First thing I would do edit is on my current working directory itself, right?
Hmm.
And probably if I do that edit, I will not push it unless I check and verify my Docker build still works fine.
Hmm. Hmm. Hmm.
So it's always that I will check the Docker build happening on my local machine fine, and then only I will push the code. It's not the other way around that first I will push the code and then I will pull the code and then I will run the Docker build command. Did you hear that?
Yes, yes.
Mhm. Okay, so coming back to the original question, why do you see there are some steps different from what I was running on my local machine, but the Docker file, instructions are different? Any answers to it? Even here I'm running flask app, there I am running some other another command as well. Okay, for one question, do you understand all these commands, Docker file directives? So I think
Uh,
always knows it, right?
yes, a bit.
Yeah,
Not.
what about you, man?
I know about that.
You know about it or you don't know about it?
I know.
You know. Then my question here is, this you understand, right? Because I have to install the Python. I'm copying requirements.txt. Okay, why
Okay.
am I not copying everything in my machine, like in my current working directory? Why I'm only just copying the requirements.txt? And why I'm not even doing this Python -3 virtual environment? I'm not creating that virtual environment in the Docker file. Why
Actually,
I'm
you have selected the base image as platform Linux. So, and you have also mentioned that in the base, in the first line, Python latest. So, you require the Python latest version, maybe Python 3 version. So, that's why you have mentioned in the base image, and you have mentioned the Python latest. So, you require the two conditions in the first line you have mentioned. So that's why we have
But
not.
actually,
So that's why we have not like mentioned this Python 3 environment versions, what type of environments you require. The details are not added in the Docker image, right? Docker file.
I got your response, but then another question is, what are virtual environments in
so
Python?
what actually is we are using the Docker for the create not for not creating the virtual environments because we are using a base version and we have already separated from our local system, so we do not need any virtual environments in Python also.
Mhm. So what does virtual environment do normally?
It will separate all the Python versions, or like if we are running multiple Python applications in our local system, so then we need to create different virtual environments in Python. But in our requirement like Docker, we're using only one Python application. So for one particular application, we don't need any virtual environments. But if in case we are going with multiple applications, then we may need another environment.
Hmm. I get your answer. Your answer is also correct, but I understand. Like, if I would explain, I would explain it from the code, and you don't have the liberty right now. So yeah, I appreciate what you could have done the best. You have did it, but if I have to tell here, because I have the access to code, right? Like, so I will talk more about it so that even always understand. virtual environment in Python allows you to set different requirements for different, Python applications. For example, I had installed a lot many things, right? These three things, but those, not only these three libraries have been installed, more now these three libraries would have been dependent on other Python libraries, right? So all those got in, kind of downloaded into a local working directory here. And whatever, whenever I'm invoking the virtual environment, right, whenever I am activating this virtual environment, it is fetching the dependencies from here. Okay. Otherwise, there could be a problem that if one of my Python app, let's say I have two Python apps in my machine, right? Python app 1 and the Python app 2, right? And Python app 2 requires Flask, but version 1.0.0. And this one requires Flask, okay, 2.0.0. Then it would be a problem, right? If both the Flask is in the same place, installed at the same place, then this Python 1, either Python, if you do the pip install requirements Python 1, it will basically, download this. But when you go to your second project and do the pip install, it will override the Flask, kind of library, and then install this. So that will create confusion. So we create the virtual environments to tell Python that fetch the dependencies and manage the dependencies in the local working directory itself, which is the env directory. And that is where I have, created the cat readme.md, right? So that is where I have created the first the virtual environment. venv is to create the virtual environment. That is the command and the directory name that you want to give. And then from within that directory, I'm, activating the virtual environment, and then only I'm doing any of my Python related stuff, right? Like installing the dependencies, right? Or managing it. But in Docker container, as I mentioned, Docker containers allows you to run the app in isolation, and I don't intend to run any other Flask app in this, container. So I probably don't need to create the virtual environments as well, right? So I'm good to, continue with the pip install requirements.txt without creating the virtual environment. Okay. Are we good on this? Things become easier when you have containerized environment. Okay. You don't have to do this much of juggling. Okay. Second thing, I was running Flask app here. Okay. Flask hyphen app. The command that here in the container would execute is the waitress serve. Why so? Why am I not running the Flask? I will give you some hint as well. Let me run this command Flask at hello world run. Where is it? Sorry. I have to first activate maybe source and then run Flask. So yeah, now tell me, why would I run the waitress serve and then hello world app there, not the Flask hyphen app hello world run? Any answers to that? If no idea, I think you should look at the logs. You should look at the logs when I ran the Flask app. What does it say? This gives a warning, right? It gives a warning saying that this is a development server. Do not use it in a production deployment. So if I create a container, right, running this command, and we all agreed that containers allows you to, basically create the image and propagate that image across all the environments, the same image which was using some kind of command which was intended for only development purposes will go till production, and that would be a security vulnerability, right? Probably maybe a weeks of effort or 2 weeks of, I think you people are working in the sprints or scrums, right? Something like that, like in iterative manner. So you have some features to be deployed. Okay. So you work on that features for 2 weeks. And then when you need to deploy, probably the DevOps person or SRE person, or I don't know, whoever security person might say, I can't let you proceed. Why? Because you are using something which is not intended for production. You might have been making it run in the dev environment, QA environment, staging environment, that's fine, but not in production. In production, we don't do that here. Okay. So you get that? That's why I made this Docker file to run waitress serve, which is kind of, I will not say that it's the only way to run it, but definitely the Flask app hyphen hello world run is not the intended way to run a production Python server. Okay. Is that good with everyone? And that is where I have waitress serve. You can definitely go and check. I'm not saying that it's the only way to do it, but definitely it's one of the correct way, right, to use waitress serve. You can choose whatever you want. It's up to you. Okay, if you know better, like you know WSGI server, how to use a production grade. In Python you have something called UWSGI server. So there are different implementations of it. Figured out that waitress serve was easier to use, so I used it. But and I use waitress serve to do it. It does not give me any complaints around, like, it's not, it's just a development server, so do not use it for production deployment, something like that. So fine, if you are good with this, now like how to create a Docker image. And now what I need to do is I just need to say Docker build. I can say the context is dot and minus t. I don't need to activate even the source, right? Like I can do deactivate and disable the virtual environment for Python. Okay. And just go ahead with the Docker build command, right? So it will execute one step at a time, and you see 1 out of 4. It means like there are 4 steps, right? So let me open this file, Docker file. So you have first step, second step, third step, fourth step, fifth, sixth. There are 6 steps, right? But it says 1 out of 4. So okay, let's see what are the steps it is count, like what does Docker image building counts a step as. Okay, so first of all, we know that the first step is being counted. Okay, so let's mark it something like that. So let's call it as first step. Okay, it is kind of pulling the Docker image. Okay, and it is taking time. Definitely I should have used a thin image, so there are ways to use a thin image as well. So it matters like what kind of image you are building on. So if Python latest is a image with a lot of stuff, there are some slim images available as well on hub.docker.com. So if I would have used a slim image, it would have been easier or faster. Right now you can see that it's basically downloading it. It's 211 MBs. So it is trying to bring, I have the Docker daemon, but it did not have this image. So it is bringing that image from the hub.docker.com. But you might not see that hub.docker.com here, right? But the API is on the docker. Like the API you access is through docker.io, like your your CLI access that. But if you have to see the web page, it's hub.docker.com. Okay. So don't get confused about it. Like what is docker.io? It is doing second out of 4, which is the copy requirements.txt. Okay, second. Then third it's pip install. Okay, fine. The fourth is copy command, right? Okay, what about these 2 steps then, right? Are these 2 steps being executed as part of building the image? No. Why? Because these 2 steps will come in effect when I run the image as a container, right? So when a container has to execute, right? So when we said like we have a container, right? We have a container. So a container is what? A container is a running process. So what process would run within the container is the one command that you gave here, right? Before that, if you have an image, a Docker image, right, that you will run as a a container, it does not need to run the waitress serve, keep the waitress serve running inside the image, right? Because it just has the some files, like it needed the base image files, it needs the requirements.txt, it ran the pip install requirements.txt and got the Python libraries. It also copied your source code, which was hello world.py. This image does not need to expose port 3000 yet, and this image does not need to run the waitress serve yet. It does not need to run the server here, right? Once this image is actually run as a process or as a container, then this command will execute. Okay, are we good with this? Like, what is a Docker image versus a container? A Docker image is the blueprint, and mostly you will see here this blueprint. But now you know what to say. Docker image have all the files, dependencies, and operating system details, and the command to even execute when it runs as a container. But the command does not execute when the image is getting built. Okay. And what is a container? The container is just a process running within a namespace and a control group. And now a cross question would be, see, this cross question would only come from a person who is new, right? Like who was not expecting to hear this from you. So the cross question would be, no, tell me what are containers, what are images and what are containers? What is the difference between image and container? And now you basically pull out your, the ace card, like you have been hiding it under your pocket. Okay. And then you now show that, image is the things which has all the dependencies, and when it runs as a container, then it runs the command in it, and along with all the files copied within the particular namespace and the control group, right, in the container fashion. Okay. Now there's a warning you see when I did a Docker build. We'll ignore that warning for now. I can always fix it, but we'll focus on that later. Okay. For now, if I have build that image probably and also name that image, so I should see it Docker images ls, right? Okay, I did build it, so Docker images, I should see it, right? Okay, fine. I did not know like Docker images ls does not work. Fine, I don't know why it happened, but you see 3 minutes ago I did create a this image, and it is size 1 GB, and that's why it took so much time. Okay. Now I want to do one thing. Okay, can I run this image? Okay, run, and I will say it as Docker run hello world. I have to give the image name, version 3.0.0. I hope that was the name. Yeah, it says unable to find locally. It should not have said that. Probably it's the underscore, right? See, that was the warning even while building. The requested image platform is Linux AMD64, does not match with the detected host platform. So it is saying that you can face some issues because my host platform is ARM64. That's not about, it's not the matter of about the operating system, but it's more about the chipset difference, right? So I don't have an Intel chipset. I have a, this is M1, right? So the processor, the chipset architecture is different, but still I would say like I will ignore the warning, because if I try to access this, right, uh localhost 3000, it should work, right? It's not working. It's not working. But it says that it is working, right? The container says it is working. So let me do one thing. Let me execute a shell inside the container, but I don't need I don't know the container name yet. Container. So that is where I will say Docker images showed me the the images, but Docker ps will show me the running containers, and one of the running container is this one, and the container id is this. So I cannot run Docker exec hello world version 3 because it's the image. I have to enter inside the container and not the image. So that's the difference between the container and an image, right? Docker exec, I can give the container id, and I can tell me what command I want to execute. I want to execute sh. Yeah, it got executed, but I did not see, like I don't see that I am inside that container, because if I see the host name, it would be my host machine name, right? MacBook Pro. So probably when you execute a command, you also have to say that you want to execute it based on the command. You are saying that, hey, please run this, execute this command, and have an interactive terminal associated with this. So hyphen I is your interaction and T is your terminal. And now you run, you get this thing, right? So it depends upon the command that what you want to run. If you want to just run a ls command, probably you don't need it. But if you want to run the sh command, assign a terminal to this, and then also have the interaction with it, so hyphen it is required. So now if I do a curl, I hope everyone knows curl. What is curl? So it allows you to create a http web request from the CLI. Okay, so just like how you would open some http endpoint in the browser, I can also hit a here. Within the container, the local host stands for what? The container itself. It does not, this local host does not mean that my machine. So from within the container, I'm able to access the server, but not outside, because my browser is not running inside the container, right? The client is not running here inside the container. Okay. So my browser is still in my host machine. So there should be a way to expose, right? Now you might say, like, already there was expose, right? So expose is more about person who is reading the Docker file to understand, okay, what the application might be running on inside the container, but it does not basically exposes the it is more about the intent and notifying the people who are reading the Docker file to better understand what are the ports that might should be published. Okay, but it does not publishes the port outside the container. So for that, you have to run it with -p. Like, you have to say -p is short form, but -p stands for publishing the port, and I can say 3000 port 3000 port 3000. Now the problem here is, now the order matters, right? So you cannot give -p after the image name, you have to give it before only. So that is the problem. I don't find it good, but that's fine. Okay, now let's try to access it. Okay, now it works, right? So that is how you containerize your application. And if you want to expose it outside your, like, you want to expose the ports or network connectivity outside, you have to publish the ports, right? So that it maps your host port to some of the containers ports. Okay, fine. Is that good with everyone? Okay, now I have, what do I have? Let's see. So we have containerized app. So if you want to create multi-container apps, so you can understand that if let's say you have database, you have you have API, and you have a front end. All those three containers need to talk to each other, right? Otherwise, how would they operate? So for example, what I'm trying to say here is, if I run this, right? Okay, and I run another container. Okay, okay, and from here, even though I know the host name of it, okay, I know the host name of this. How? I will tell you. If I run the docker ps, okay, the host name of the one, this which is running my Python is this. Okay, this is the host name of the container and the container ID as well, right? So I know that. But if I try to do a curl on this, it will not work. Oh, curl not found, but there's a wget maybe. Okay, so if I can run wget, but that will not work. Okay, see, bad address, or if I try even localhost, right? Like, it will not work for sure, right? Okay, not found, connecting local. There's nothing running inside the busy box container, right? But there's something running on a different container. So probably we know that if two containers need to talk to each other, they are in a different network namespace altogether, right? So probably there should be a way to create to share a network namespace in, like, in Docker world. So for that, uh, if you want to do it, there is an example to it, right? So you create a network first, a Docker network, and then when you create the containers, right, when you run the containers, you attach this network to it, right? So that both the containers get attached to this particular network and they can basically access each other. Okay, so there's a, I would say there's a example to it. I will say fine, but these are all commands that you have to execute, but there should be a better way, right? Like rather than manually going and running these commands, I would should be able, just like how I'm able to give the Docker image, how to build the Docker image, I'm able to give it in the Docker file. There should be a way to run multiple apps and also connect them together through a file, and that is what a Docker compose file means. Okay. um, so let's say to-do app has to connect to the MySQL app, so probably they will have to share the Docker network. But automate multiple container apps is the thing. And if you want to check the Docker compose example, you can check Docker compose example. Yeah, I think they have a WordPress example, okay, which they tell. Yeah, compose and WordPress quick start. Okay. Yeah, I think that the quick start compose and WordPress will let you know, like you can basically create a Docker compose which where you have this database and you have this WordPress, and if WordPress needs to connect to the database, what it needs to do is just use the service name as the host name, and that's all, right? So basically one service, one a contain, like any calls inside this WordPress service, okay, will be able to reach to the DB service by using the host name DB. So let's say by default the database port is 3306. So within this WordPress container, if you run any of the SQL queries and point it to DB 3306, it will be able to reach to the other container because they both are sharing the same network namespace. Okay, is that good with everyone? Now if you like, you might say like, I also want to see, like, Sagar, can you show it to us, right? So yeah, definitely I can show it to you, but then I feel like first you should try it on your own because all these things are not hidden, and definitely you can come with a better questions after you have, you know practiced this basics. Okay, and yeah, that's all for today I had planned. uh, if you have any questions you can ask, and even if you want to ask any, career related advice or suggestions or any, like whatever you want to share, you can share. Okay, so I'm stopping the recording, or if somebody has anything related to Docker or whatever I've talked, you can ask the question. Do you want to ask any question related to the stuff that I had did till now?
So whenever we are creating an container for an image, always the container ID will be the same, or for a different run, so it will be different. That's the-
Okay, yes, it will be different. So for example, let me create another. Okay, definitely I cannot expose on the same port, so I will not even publish the port, right? For I will not really care about it. Now this is also running. Now if I see the Docker ps, you can see multiple containers are using the, sorry, multiple containers are using the same image, right? But they are like the blueprint is same. Okay, so the image, the files are all the same, but the processes are different. And this process is isolated because they are two different containers from the same image. So probably everything is different then, right? It's not just like, even if the container ID is same, so what? Like what does it really mean that you can have multiple instances of the same image, just like you can have multiple Windows operating system, right? Running one on your machine, one on my machine, right? Both of us has Windows, right? Both of us have Windows operating system image, right? But then your files is something I can't see, and your, like whatever you create after that, right, I don't get to see it, and whatever I create you don't get to see it, right? So it, or both the processes are isolated, right? Or both the machines are two different things. So yeah, a container can, like from a single image you can create n number of containers that will not share anything with each other.
Okay. So we compile, we build our container. So like our Docker file, we build that. So the file size is 1 GB around. So what that actually contains? Can you give me the brief? what that 1 GB consists of. Like we have the Linux base image, and we have our Git code, GitHub code, like Flask app code.
I don't remember it, but there is a way. Like in Docker, if you remember, like first step, second, third step, right? So each Docker image are consisting of the layers. I can definitely go into it in the like in the next sections. There are those things, but there's a command to actually see it. Let me just check it. I normally on day-to-day basis don't use it, but yeah, Docker image inspect. I guess yes, this will work. Docker image inspect, and then I need to give the image name, I guess, or the image ID. But I think image name will be. So you see now, okay. So this is probably the base image itself is taking a lot of size. I don't know where is the size. This is the size. I think it should be in bytes or KB. I don't know. I have to convert it. Probably it makes sense that you go read and basically
Yeah,
this.
thank you.
Yeah, and the second thing is yeah. So if you see how many layers are there, you can see probably the base image layer would only consist a lot of things. The other layers are very small. So probably yeah. And what do I need to so let's say this. See where is it? Okay, probably I would have to Docker image layer size. There is a command for sure. I'm not sure like where is find the layers and the layer size of the Docker image. Dive written, okay, it's a plugin written in the dive Docker images minus a, and
And
then
can we reduce that size from 1 GB to some
yes,
MB?
then probably if it is the okay, what I can do is I can show you one of my hub.docker.com. I would have some images there, right, on my personal. I have created some under my just like you have GitHub, right? You have GitHub profile. You have something called Docker Hub profile, and I can have my public Docker images there. So one of this is hello world. I think this one is in the Python one. And if you see the image tag one version 1.00, and you see now, right?
Hmm.
Now you see the size, right, of each layer, which is from the base image. This is something from the base image, but yeah, like see what I did was till the copy requirements, right? Dot like this is coming from the build kit, right? Like whatever I was building, no sorry, don't worry about the build kit, but yeah, these are the steps which I ran, right? This one wait test, right? But other than that, the above ones, and these are like this one took 6.31 MB. There was a pip install, but I did not do it, so probably it's something different. But I copied hello world.py, I copied requirements.txt. I That's all I did. Other than that, everything came from the base image. And yeah, now you know how to check the size, right?
Yes, thank you.
There would be an equivalent way to do it in the CLI as well, I'm saying. I just don't know whether it would be easier or harder, or maybe how visually appealing it would be. Okay, did you get that? Versus here, it's very fairly simple to see it. Okay,
Okay.
if I push my Docker image now, I can basically see it like it's just like version 3.00. I will push it and I will see it. Okay.
Yes, Sagar,
Yeah, go
actually,
ahead.
when we
Your voice is very low, by the way. Yeah, go ahead.
now it's clear.
Yeah, it is good.
Okay, after we create a container out of image and we started a container, okay. So after running the container, we that application we no longer needed. So we have stopped that container. We may require it later, maybe. So we
No.
have so we have stopped that container.
So
Okay.
you have the image, right? Why did
We
you stop the container? Why did you stop the container?
because we may not longer needed.
So when no longer needed, no longer needed, why would I again go back and start it
So we
again?
will definitely we will directly delete that container
Yeah, you
if we
can
don't require.
feel free to it. Like basically create a new container, na, from the new. There is a way to do it. There could be an
Mm-hmm.
interview question also like this. How
Mm-hmm.
to start a stopped container?
हाँ हाँ हाँ.
Why
So
would you
what
do it? What's the use case? What's the use case? Tell me the use case. I can tell you the answer. I know there is an answer, but like, why would I tell it? Like, so for you, yes, there is
uh,
a way. You can definitely go and figure it out, but then you can ask one more question. But I never use it. If I have to be like, if I am there in the interview, I would have said, like, if you ask me right now, just like what you
mm-hmm.
asked, I would say there is a way, but I have never used it, so I don't remember. Is there a way? Yes, definitely, because a container is a process. If a process can be stopped, so probably a process can be restarted again, because name in the namespaces and control groups, if those give the features, why not Docker will give it?
Okay.
So just running the Docker, now there are now I know, right? There is a way to stop the container, and there is a way to remove the namespaces and control groups as well, right? So now you don't say that, hey, Docker stop just stops the container, and Docker kill just, and there's a subtle differences, but it's a lot of difference if you go in depth. But yeah, Docker stop and Docker kill can both stop the instances. The way it does, it's different. But then Docker RM, right? Okay, I think
Mm.
Docker RM actually deletes the
Stops them.
container like, namespace and everything from the records, right? So for example, if I show you Docker PS, it will show only the running containers, but what about the exited containers? Here are all these, right?
Mm-hmm.
So now my question is, why would I start the exited container? That I don't know. I can definitely, there would be a command to start the exited container, right? Okay,
Mm-hmm.
I don't see the use case, so I don't know right now.
So I have another question for related to my career.
But
So
no,
we
we can't do it right now because it's about time, 12 p.m. Sorry, guys. There's something else planned after this. So feel free to reach any further questions. Feel free to maybe ping us on our social media channels. Okay.
okay.
Bye.
Sure,
Thanks.
sir.